So,
I actually did them with integers.
Graphify? Get them.
Seniors last day.
16.
How was the fifth or something?
I wish we would do our daily check. Either. You didn't give you another 2 minutes. I see 1 or 2 wrapping up. Okay. There?
Just gotta do the lines.
Okay. Just got to do the lines, and that's exactly what it boiled down to, right? Tangent was the goof of the troop, but secant and cosecant was just, hey, do the same stuff you did, blow it outwards. Okay, turned out to not be so bad. They look very complex, but they're not. All right. We start with vertical shift or midline. And if our amplitude is 5, I'm just going to go 5 north and south of that. And you should have seen, especially with the tangent ones, when I showed you how do you fit this kind of graph to someone else's axes. Sometimes you end up with compound numbers on there. So this just becomes square root of 2 plus 5, or 5 plus square root of 2, and square root of 2 minus 5, or negative 5 plus square root of 2. Okay, either one works, fine. The more appropriate one is to have the rational number before the irrational, but this way we see the plus or minus 5. Phase shift. Still negative c over b. That part hasn't changed. So we're going to be at 3 pi over 2. But yeah, let's put these outside so it's easier to see everything. Period is still 2 pi over b, which is just pi. So if I add a pi to that, I'm at 5 pi over 2. If I subtract a pi from that, I'm at just pi over 2. And green, there we go. My quarter marks are going to be pi over 4 increments. So I take 3 pi over 2 or 6 pi over 4, keep adding pi over 4 increments, getting 7 pi over 4, 8 pi over 4, reduce it, 9 pi over 4, 10 pi over 4, they are reduced, 5 pi over 4, 4 pi over 4, reduce it, 3 pi over 4, 2 pi over 4, they are reduced, and then secant is a reciprocal of who? Cosine. So cosine normally starts at maximum, minimum, or midline. Normally at the maximum. This has a negative, so minimum. So I start down here, and I do the dance. Middle up, middle down. Middle up, middle down. Now, cosine would have looked like this. But this is secant. Secant is reciprocal, so it's a reciprocal of every one of these values. The reciprocal of 1, because remember it's a shift, is still 1. So those are going to stay put. But the reciprocal of 0, if I take a number divided by 0, its reciprocal is 0 divided by a number, which is impossible, and we get asymptotes. So instead of this curve, every one of those x-intercepts is going to become a vertical asymptote. And the reciprocal of 1/2 is 2. The reciprocal of 1/2 is 2. So I get all of these hills, all these crests and troughs become maximums and minimums of u's. I don't say u's because I don't want to say parabolas, but They're not actually quadratic, but we're going to be in those areas. It's just this cosine part isn't there. Okay? So set everything up just like cosine, and then blow it all outwards. Okay? I'm looking forward. Do you have vertical axis? You know how to do your shift and your amplitude. That's pretty easy peasy. I'm going to say 2 for the entirety of that horizontal axis. Meaning you got your phase shift, you did your quarter marks right, and all that kind of business. 1 for you specifically started here and did the cosine values. Like you set it up like a cosine. And then 1 for you exploded it all outwards into the U's and asymptotes. What you do want to be careful about, I have seen some kids do this. This is very, very, very bad. Oh, there we go. I've seen a few kids, instead of making the U's go down this way, they do them like this. Like, don't do that. Some kids will get confused about maximums become minimums kind of thing, and they'll just take this lump and just extend it downwards instead. But now you would have the entire thing infinitely fails, sometimes repeatedly, your horizontal line test, bringing us into today's inverse functions. Okay? So, heard they just shoved you out in the commons on Friday again, huh? Yeah. I have things to say, but I shouldn't say them. I have things to say, but I'm not supposed to say them.
Your other class had one, though, but we didn't have one. No, not the.
My White 4 algebra did.
Yeah.
Basically, PreCalc is self-sufficient, and we just need a warm body to make sure no one's burning anything. Because most subs can't do basic algebra half with equations, much less actually teach a math course. Okay? It's kind of a meme among math teachers that if you ever get a sub and you hear the words, well, I don't know, I'm just a gym teacher, you just cringe. So it was all going to have to be less than video anyway. But what?
Well, the video was fine, but it didn't. Never mind. Fine. I just never mind.
Okay. Anyway, remind me. Is this a function? How do you know?
It has value.
Specifically, what kind of test?
Vertical.
The vertical line test. Okay. Its inverse, if you remember, is when I swap x and y, solve for y, and get this. Is that a function? The inverse of it is not a function because it doesn't pass vertical line test. I could have known that by doing, you remember, horizontal line test on the original. That tells me that its inverse does not have one. And you may remember from back when we did these, because of this, you would see that tacked on afterwards. See, if I do that, I restrict my range. I say, I don't want this entire thing. I'm just going to look at this part of it. And now it is a function. Its inverse is also a function. I won't have a plus or a minus on here because of my restriction. I'll be good to go. We got to do the same thing with our trig functions, because a trig function may be a function right now, right? That passes a vertical line test. But the horizontal line test, on the other hand,
No. It fails
infinitely fails. Okay? They usually get a couple kids to be like, same. Okay? Infinitely fails the horizontal line test. So just like with other types of functions, I have to restrict it. I have to say, what is the range of values that I ever see? I go from -1 to 1. All right, pick a part of the domain where I will hit all of the values from -1 to 1 so that I see the entirety of the function. And that's just my unit circle. Okay. Of course it is. Sine is my y values, and we go from -1, -0.8-ish, -0.7-ish, -0.5, 0, 0.5, and then it just keeps on going to 1. So I see the entire range of values from -1 to 1 if I go from here to here. Problem is, if I try to do that on a number line, it looks dumb. What if I said 270 and then 300 and then 315, 330, 0, 30, 45, 60, and that was my number line. Doesn't make too much sense to have big numbers, 0, small numbers on a number line. So what we're going to do to fix that, good thing it's a circle and we know all about coterminal angles, is this may be 0 and pi over 6. To make things line up, I'll call it negative pi over 6. If this is pi over 4, I'll call it negative pi over 4. If this is pi over 3, this is negative pi over 3. Which should make sense as we're going through that. I'll go from negative pi over 2 to pi over 2 because that's how my number line looks.
Saw something I forgot on my quiz. The tangents on the undefined tangents.
Quadrantal tangent values is the number one thing that kids miss.
Yeah, you forgot. I knew what they were, and like the root of 3 and that stuff. No, I put those, but not the.
Just the zeros and undefines on the quadrantal angles. Okay. So what we're going to do is restrict this. If I only look there, now I have, just like with that parabola, if I cut it off and only look at half of it, I've got a function that I can make inverses with. We have a coordinate down here at negative pi over 2, negative 1. We have a coordinate up here at pi over 2, 1. Should make sense halfway between, right? Like pi over 4. All of the other values are still there. This is at pi over 4 and square root of 2 over 2. Okay, this is at negative pi over negative pi over 3 and negative square root of 3 over 2. Like all of those values are still on here. But if I'm not allowed to go past there, My original y equals sine of x has input an angle, output a ratio. My domain, if I restrict it, goes negative pi over 2 to pi over 2. My range, all of this is written in that entire first page for you. I'm going through it so hopefully we understand it when I start throwing graphs at you. If you pay attention to the front loading of it, the graphs are really, really easy. My range, what's the lowest and highest my y's ever go? Okay, negative 1 to 1. So what happens when I flip the script? What happens when I go to y equals the arc sine? The inverse. Remember how we make inverses? Okay. So now I'm going to put in a ratio. I'm going to get out an angle. My domain is going to be negative 1 to 1. My range can only come out as negative pi over 2 to pi over 2. Which is why we are finally there. And Mathocles comes down from the mountain with the commandments of domain. Number 1. What is the first commandment of domain? Thou shalt not divide by 0. This is bad. Number 2. An even root of a negative number is bad. My kid's on the crudes kick again, so I want to do the like, and they died. Okay. 3. Logs. What about the logs? Thou shalt not log of what? Non-positive. And we say that because it's negative numbers and 0 aren't allowed. That is bad. Well, we're going to get rule number 4 today where we want good. You are only, these say this one thing is not allowed. Commandment number 4 says you are only allowed here. The arc sine and the arc cosine of any value must be from negative 1 to 1. This is good. The 4th commandment of domain says, if I'm taking the arc sine or arc cosine of a thing, I can only do it with values from negative 1 to 1 because, look at your unit circle. That's as big as they ever get. Y'all got a calculator? Try it. Try to do the arc cosine of 5. Your calculator is just going to give you the digital bird. Say no. Okay. We'll say non-real answer or error domain, depending on which calculator brand you got. Okay? You cannot take the arc sine and arc cosine of anything outside of that domain value. Additionally, when I do, I'm only going to get answers negative pi over 2 to pi over 2. What 2 quadrants is that? From negative pi over 2 to pi over 2. Oh, we lost our quadrants. Where's negative pi over 2? North, east, south, or west? Straight south. All the way up to pi over 2. Quadrants 1 and 4. Okay? But we have to be careful that if we're in quadrant 4, we can't say 7 pi over 4. We say negative pi over 4. Okay? And that can get kind of tricky, which is why this morning when I was with the other class, I sent out the ultimate trig cheater. It has the unit circle on there, but then also it has two separate semicircles showing you the inverse trig functions. Okay, so if I take all these coordinates and, you said it, I swap domain and range, right? So I also swap all the x's and y's.
I guess I'm confused on the coordinates. Did you just make up those coordinates? Or?
Well, no, this was on the graph. Pi over 2 is where I normally have my maximum, right? Middle, up, middle, down.
Yeah.
Well, halfway in between 0 and pi over 2 is pi over 4.
Okay, yeah, so that's just like the sine of x.
Yep. So I'm going to take all these coordinates and flop them. And that's what creates, we're going to go through a lot faster now. Okay, this is just the front loading. That's what creates the inverse sine. Okay? You see how now this coordinate is 1 comma pi over 2. I swapped the coordinates.
Does it zigzag on the y? Does it zigzag on the y axis?
It's got a curve like this, like a cubic, just a little chunkier.
Yeah, but if it were to keep going,
It can't.
Oh yeah, because it can only.
We have to restrict it. In fact, this is the first function that you get that is finite. Think about every function that we've done. Isn't there an arrow running off the graph, at least in one direction?
Yeah.
These are the first finite functions that we encounter.
Theoretically, it would go.
See the closed circle.
It would zigzag.
Yeah, it would keep going like that, but because of that, it would infinitely fail my vertical line test. It wouldn't be a function.
How does it infinitely fail?
Because it fails here and here and here and here.
Yeah. Vertical, it's touching. Oh, it's touching to.
And here and here and here.
Yeah.
Okay? It's just going to keep failing over and over and over and over. So this is the first finite function you get, where I'm going to go from -1, negative pi over 2, through the values of sine until I hit 1 pi over 2 and done. Closed circle on both ends. So next to this, we are going to write that y equals the arcsine of x has a domain of -1 to 1, has a range of negative pi over 2 to pi over 2. And you see I'm using those brackets because it equals those values. That's why we got the closed circles shown. So then, think about the unit circle. Sine was what part of the coordinates? X or y? The y's. So that means cosine is the x's. What is the smallest and largest x values on the unit circle? -1 and 1 again. Cosine keeps bouncing back and forth between them. So where do the -1 and the 1 happen? Cosine of what two angles? Cosine of 0 is 1. Cosine of pi, or 180, is -1. So I'm going to do the same thing for cosine. I'm going to restrict it because cosine just keeps going and going and going and going and going. It wouldn't have an inverse function. So I say, well, the maximum value is 1. The minimum value is -1. They happen at 0 and pi. And if I go in between those values, I will hit every single one of the values of cosine. So I'm going to restrict. All this stuff is just going to disappear. if I restrict cosine to just this stuff,
Doesn't break.
now its inverse isn't going to break the rules. Okay? I take these coordinates and I flop them. I take the domain and range and I flop them. If the domain is 0 to pi, range is -1 to 1, then when I go over to my inverse, you're going to see that same thing. From -1 pi to 1 pi, or 1, 0. It's important that we know what is legal and what is not with these. This is a whole new commandment of domain. And I know you didn't touch this in geometry. Okay? So, what about tangent? Look at your tangent values.
Huh.
No, it's, you just restricted by the asymptotes.
Yeah.
Right? We had asymptotes. Because tangent takes off to infinity. Ah,
Cosine and sine take off into infinity, right?
no, they bounce between -1 and 1.
Oh.
Tangent keeps going. Remember the other day when I had us grab the calculators and say, what's the tangent of 80? 85, 89, 89.999. The further you went, you were essentially making a triangle that was ridiculously tall compared to how wide it was. Because the opposite was big and the adjacent was tiny when you hit 89.9999999, right? It's not even a triangle, it's like a sliver. And at that point, you are approaching infinity. So again, I want to look at where do I start repeating myself? Back here, it's another one of these fake cubics. Over here, it's another one of those fake cubics. So in the middle, from -pi/2 to pi/2, that's my tangent business. I want you to think of those like coordinates. Treat this kind of like when we were first talking about end behavior. Treat this as pi/2 infinity. Treat this as -pi/2 negative infinity. So swap your x's and y's. We're going to get a graph that now goes negative infinity, -pi/2, all the way up to infinity pi/2. If there were vertical asymptotes, now I'm going to get horizontal asymptotes, and my graph is going to skirt in between those like this. It's going to be that whole tangent graph flopped on its side. Okay? So that's where all of these inverses come from. Most of today is cheater graphs and look things up on the circle. Next to this, we're going to write y is arctangent of x. My domain. What's the domain of this thing? Yeah, because the range on regular tangent was. So this is going to be -infinity to infinity. Range. Where are my y's allowed to happen? Yep. -pi/2 to pi/2. Parentheses or brackets? Because I got asymptotes now. Okay. There were vertical asymptotes, so now there's horizontal. Also, if you want the cheater way to make these, when do I have a tangent value of 1? on a unit circle, tangent of what angle is 1? Pi over 4. Halfway between 0 and pi over 2 is pi over 4. 1 pi over 4. Okay? So what I would do with these is I would set up my axes, I would label those 4 points, my boundaries, and then halfway in between is 1, halfway in between is -1, and I just connect the dots. Try to keep it kind of curvy. Now, not super curvy, don't try to do this. Okay? Kind of like a cube root. Okay? I wouldn't want to do it like that. Okay? More of a lazy curve. So, that's a lot of front loading. Does everyone have their calculator and unit circle in front of them? Because the application of it is actually very simple.
You're getting by hog swallowing.
So, y equals arcsine of x. We know that our domain is -1 to 1. New commandment of domain. Range, specifically for arcsine, -pi/2 to pi/2. So when I'm doing arcsine, just like if I'm solving an equation and I have x on a denominator, the first thing I had to watch out for is can't be 0. If I had a even radical, square root, the first thing I had to do was watch out. This can't be negative. I have an arcsine. The first thing I need to make sure of is it a legal target? 1/2 is between -1 and 1. Okay, it's a legal target. We're good. So then I'm going to go to -pi/2 to pi/2. I'm in quadrants 1 and 4. Where do I see a sign value of 1/2? Because remember, these are restricted. 1/2 happens here. 1/2 also happens here. But look at the range. I am only allowed to be from -pi/2 to pi/2. I can only look in those two quadrants for answers. So yes, there is a sign value of 1/2 over here, but it's illegal. Which is why when I send out the ultimate trig cheater, it has your arcsine values only in those two quadrants, and all of these angles are labeled negatives. Yes, it is at pi/6. But don't you dare say 5 pi/6. Okay? It's been a while. That's so random. All right. -2/2. Where do I have a sign value? Okay, is that legal? Do you know what the value of that is approximately? Is it between -1 and 1? How do you know?
Because it's a small number divided by 2. Yeah, so it has to be less than 1. But it can't be less than a -1.
The two radical values that we should know just by decimals, that square root of 2 is about 1.41. Square root of 3 is about 1.73. Okay, just like you should know pi is about 3.14. Those are just values that we should know. Okay, so if I take 1.4-ish divided by 2, 0.7-ish. So that is within the realm, yes. So this is legal. I like that. Oh, that's some big brain. How many times have we had to rationalize this? Right?
Why is it 1?
Because wouldn't I multiply by square root of 2 and square root of 2 to get this?
What?
I know that this is bigger than 1. So small over big, it's going to be less than 1. That's some big brain thinking right there. I like that. I just have most kids look at the unit circle. But God, we've rationalized that thing probably 1,000 times in the last few weeks. It's a legal value, arc sign. I can only look in what 2 quadrants? So I go into quadrant 4. I look for a negative root of 2 over 2, but I can't say 7 pi over 4. So I instead say its negative counterpart, negative pi over 4. Okay? Because otherwise, you would have big number, big number, big number, big number, 0, small number, small number, small number on a number line. And that doesn't make sense. Which is why I have this. Okay? All of these are labeled as negative angles instead. Just so I know that I look here for my inverse trig functions. And then I look at C. Is 3 between negative 1 and 1? Thou shalt not. So that's just a big fat nope. Can't do it. Illegal. Do it again, those 3. They should just be about looking it up. But you do it in stages. First, is it a legal target? These are arc functions. It has to be a legal target. Because they can do it both ways. You can just write arc sign, or you can use the negative first notation. They're the same thing. It's just one's more formal, one's more old school.
It's negative 2 pi this way. So it's the same thing as 2 pi.
Isn't that inside the arc sign?
Yeah.
Wait, so would it be 0?
Negative 2 times pi? Is that a value between negative 1 and 1?
Yeah, it's right there.
No.
No,
What?
yeah, okay. Yeah, I was getting all confused.
Wait.
They threw the pi in there to mess with you.
Okay.
Got him.
Negative.
Okay. Max just activated my trap card. Yu-Gi-Oh? It's a meme. No. That's saying the arc sign of about negative 6 something.
Is that in between negative 1 and 1 then?
No! So this one, we just got to say a big fat nope. Can't do it. The pi is there just to mess with you. Literally to make you look at 2 pi. But, yo, I'm putting in a ratio and getting out an angle. I should not be putting in an angle to an arc function. Okay? Arc sine of square root of 3 over 2, that's at pi over 3. Negative 1 is way downtown at negative pi over 2. Okay?
Oh, I had negative pi over 2, but I understand.
Dude, imagine. How to do it.
Another way to think about this is I'm just doing arc sign. If it's a positive or a negative, it's just in those 2 quadrants. Positive is in quadrant 1, negative has to be in quadrant 4. Just restrict yourself to only looking there. Okay, cosine. we write
Okay. Yeah, it's up downhill.
60 miles an hour.
Oh, that's how much.
You ever ridden a bike past 20, 30 miles an hour?
I know. He's saying he.
It is terrifying.
Yeah, you're not going 60
I rode
miles
my
an hour.
Oh, dude, I rode my motorcycle to school today, and I went fast. Like, almost blew me off.
What do you mean your motorcycle?
Dad's motorcycle.
Dad's.
It's like when
It's just
various people get worked up about sports ball. And they say, yeah, we just sucked it up this weekend like they couldn't do anything right. And I'm like, who's we? You weren't playing? Anyway, domain. We already said it. What's a domain on arc cosine going to be now? What's legal targets? Fourth commandment of domain. Arc cosine is from -1 to 1. Range. What was different about cosine? From 0 to pi. No negatives here. We're going to be up in quadrants 1 and 2. Okay, and if you want to draw that little semicircle again, we're in quadrant 1 and 2. Here's my positive values, here's my negative values. So, negative root of 2 over 2, is it legal?
Yes. No. Yes. It is.
Okay, yes, no, yes.
Sure.
Yes, it is. Okay, it's about 0.7-ish. And, is that 3 pi over 4? I just look it up. Arc cosine, -2. Is it a legal target?
No.
No. So that's it. Oh, it can be a negative. It's the fact that it's more than 1. Okay, and arc cosine of 0. I can do that. That's between -1 and 1.
God, it's just pi over 2.
Arc sine of 0 would be pi over 2. Arc cosine is the x values.
Wait, what? No, it's pi over 2.
Oh, sorry, I got that backwards. I'm tired.
Rounded.
Yeah, I'm gonna call myself on that. That was. Yeah, y'all. It was a long weekend. Okay, so it is just look it up, and apparently don't listen to me when I do mental math. Go. Do them again. Look them up. But again, make sure that it's legal. And it is not uncommon for them to throw random pies in here just to try to mess you up. Not because it's a decimal, but because it's greater than 1.
What about your truck? Oh, I thought you meant like your real truck.
Real truck. That's just over to the house.
They sold it.
Oh, it's there, so like whatever.
Okay, I heard a 5 pi over 6, a no, and a 2 pi over 3. Okay. Now, said they will try to mess with you. Which of those is possible?
It's tough, I don't know why. Not more comfortable, it's actually more issue.
Remember, these are arc cosine. I put in a ratio. Someone just put a pi in there as part of the ratio to mess with you and have you think of angles.
Is Emrys wrong? Would it be 1/2? For pi over
Okay, you
pi?
just missed everything I said. Arc cosine, I put in ratios, not angles.
Oh, so that's just not a thing.
So you have to think of these as raw numbers, not a rotation.
That's over 1.
Not necessarily, because the first one, divide them out. Take pi and divide it by 3. Is it between -1 and 1? No.
But the second one does.
Okay. But the second one, if I take 3-ish divided by 6, I'm going to get around 1/2. That's in my legal range. I just dump it in my calculator and I say it's approximately this. Because what you're saying right here is I have a triangle such that the adjacent is pi units long and the radius is 6. Go tell me the angle. It would be 0.524 radians. You would have to state radians on there. How many degrees is that? Okay. Right now I am in radians. If I were to try to do the arc cosine of, come on, Frank. I'm recording this time. Laptops can't handle. If I try to do this over 3, it's just going to tell me, no, you can't do that because it's a value outside of -1 and 1. Okay. If I instead, come on, Frank, switch that over to pi over 6, now it's perfectly legal. It's going to tell me this much radian. Well, I don't want that much radian. So I'll take that many radians times 180 over pi. I could switch my mode and then redo it, yeah. But if I just convert over to degrees with my conversion factor, this was about 58 and change. Okay, so I'd either say about this many radians or about that many degrees. If I get one of those weirdos, how about arctangent? Y is arctangent of x. My domain, what is it now?
All reals.
Everybody. Which means I'm always going to have a legal target. That's why commandment number 4 is only arcsine, arccosine. The range, on the other hand, is from -pi/2 to pi/2. And parentheses, not brackets. That's right. So, good thing we wrote all of our tangent values next to our angles. Also, if you need that, right, -pi/2 to pi/2 looks like this in quadrants 1 and 4. Yep. So, tangent, square root of 3. I know it's a legal target because there's no restrictions there. What angle has a tangent value of square root of 3? That's it. Just look it up. Okay. Arctangent of 0. Where do I have a tangent value of 0? at 0. Okay. Now, curious, what's the tangent of pi over 2? What is the tangent of pi over 2?
Has to be 1 because that's your minus.
Look at your circle.
Oh, it's no answer.
Undefined, right? So here's my question for you. If the tangent of pi over 2 is undefined, can I do arctangent of undefined to get pi over 2?
Well, there's 2 answers.
Okay, there's 2 answers.
3 pi over 2. Or
At negative pi over 2 and pi over 2, this happens, but those are asymptotes. Asymptotes don't exist. How can I plug in no? Like, if you can figure out how to do that on a calculator, how do I plug in undefined? Like, could I get really creative and say the arctangent of and then do 1 over 0? I mean, that's undefined. Could I do that and would it actually tell me? And it would say, you can't do that. No, I can't plug in an undefined. So no, this does not work, even though it seems kind of intuitive that you can go back and forth between ratios and angles. I can't get away with that. All right, go. Look them up.
They're right here.
oh no.
I don't think there's. Have you started those yet?
No. Grading through the unit circle tests. No, it's been kind of a dumpster fire right now where everything is trying to happen at once. So
That does work, then you just type in the exact value.
Why are you putting
Negative 30. I'm doing this right, am I?
do it for real, not just the calculator tells you an answer.
I guess I don't understand. I thought.
Look on your unit circle in quadrants 1 and 4.
Oh.
Where do you see a tangent value of negative root of 3 over 3?
Right there.
Okay,
So then it's just down.
so I'd call it a negative pi over 6.
We're getting there.
Negative pi over 6 and negative pi over 4.
Bussin'.
Isn't it?
Aren't you go orthodontist in the sport?
Okay.
Oh, it is. I don't know why.
All right. Just to make sure that we can handle when things get switched up, because that was practice arcsine, practice arccosine, practice arctangent. Can you do this when you've got all of the above? And I want to see if you can puzzle out what to do with numbers 6 and 8. I think you can. We've done composition of functions before. This is just the trig version of fog and goth. Oh yeah, that's coming.
No, I hate those. Those are what they do from an A to an A-minus at the end of the semester.
Oh no! The humanity!
No joke.
You're not joking.
Yeah.
I got a 98.
Shut up.
You
didn't learn anything.
Yeah, I've been struggling.
He's like, I got A.
Look them up. See if you can figure out what to do with 6 and 8. We'll say they're just like Fogg and Goff, our compositions. Oh, yeah, sorry about that. That's just a straight up, like, typo. Because if I say arc sign, but then also have the -1 there,
Don't think it's allowed.
isn't that like arc sign?
Yeah.
So just, there, arc sign. No, that says what it says.
Wait, what? We don't. That's not a value.
Look at the function. See, once we start mixing them all together,
Yeah.
it's just regular tangent, dude. Go to -3 pi over 2 and tell me what the tangent is.
Sine and -1 of cosine. Cosine pi over
Arc
is cosine pi over 3 is 1/2 arc sine of 1/2. The arc sine of 1/2 is just 1/2. Right?
No.
All of these are
Go look for where the angle has a sine value.
cosine of 1.
I got -5 or 6 for 3.
Oh, the arc sine of 1/2 is pi over 3.
Looks like
What?
Someone's screaming.
Yeah.
It's either that or one of those videos of a cat getting a bath.
oh my god.
No, no. I don't know what's going on out there. Okay, arc sine. Arc sine is in these two quadrants, right? So, arc sine of -√3 over 2, I go down into this quadrant and I look for where I got -√3 over 2 as my sine value. I can't say 11 pi over 6, so I have to say -pi over 6. Next one, tangent of -3 pi over 2. They're just messing with me now, because that isn't arctangent. It's plain old tangent. So go 1 pi over 2, 2 pi over 2, 3 pi over 2. What's the tangent value at -3 pi over 2?
Undefined.
Yeah, just undefined. Because it's 1 divided by 0, can't do that. Okay. Next one, arctangent of. Arctangent is, again, in these two quadrants. Arctangent of a -√3 over 3 happens right about there at -pi over 6 again. Arc sine of negative 1/2. Hey, look at that. It's in the same spot. There's a theme here. Okay, the other ones. Take them in pieces.
So I actually did it the exact same.
We're confuzzled?
So shouldn't 5 be negative pi over 3?
You mean 5 pi over 6?
Oh, yeah.
Oh my gosh, bro, you're so smart.
Sorry about
I've
that.
been staring at that for like.
Wait, why is it negative pi over?
I had pi over.
I did cosine instead of sine.
I was like, what the heck?
Why am I
I was thinking like.
I'm so messed up.
No, the sine value at negative pi over 6 is negative 1/2. This is negative root of 3 over 2. It's here.
You did the cosine.
I did cosine instead of
I
sine.
know, I thought.
Oopsed.
Oh, it's sine, so it's
Yeah.
down here, so then it
I
would be
oopsed.
5 pi over 3.
Yeah.
Negative pi over 3, got it.
No, you got it. Okay, take these in pieces. Regular cosine, is it restricted or not? No. Okay, what's cosine of pi over 3? 1/2. So now, do the arc cosine of 1/2. Is arc cosine restricted? Yes. So now I have to look in these two quadrants. Where is the cosine value 1/2?
Pi over 3.
At pi over 3. You would think so because we've already done inverses. Remember, if I do the function of the inverse function of x? Remember Pfaffy? If I do the function of the inverse function of, everyone, look straight ahead, go 90 degrees to the right. Go 90 degrees to the left. You get the one kid who went all the way over to 180. When you look straight ahead, the input is the output, right? The inverse function with the regular function. Okay, if they're both cosine, if it's cosine and arc cosine, where we have to be careful is it's not always true now that I have these restrictions. Because what if I did the arc cosine of the cosine of 5 pi over 3? Is there a restriction on regular cosine? No. Okay, what's the cosine of 5 pi over 3? Okay, now it's arc cosine. Is there a restriction on arc cosine? Quadrants 1 and 2. It's not going to spit 5 pi over 3 out. Now it's going to spit out regular 1 pi over 3. Okay, so they don't always just cancel out like that. We have to watch out for our restrictions with the arc functions. If I said the cosine of pi over 3, we already said that's 1/2, and then I threw an arc sine on it. I could still do that. What angle has a sine value of 1/2? Pi over 6. Okay. Yep. And that's kind of where we're starting off tomorrow, is more of these. I just wanted to see if y'all could figure it out.
And that's where we're leaving off today?
No, not even close. We got more graphing to do, bud. These are the parent graphs. And these parent graphs are all going to be changed according to the ancient laws of Algebra 2. Oops. Y'all remember these? What does A do?
Vertical stretch.
It's a vertical stretch and compression. Also vertical reflections. These, we're not going to say amplitude, we're not going to say phase shift, nothing like that. That is just for the normal trig functions. What, if this is a vertical stretch and compression, what is this guy?
Horizontal stretch.
And remember that it's backwards. It's by the reciprocal, by 1 over b. Okay, think about, again, you're saving up for a car. It's going to take you this long. It's going to take you 10 more months to get the money for it. And then your input gets doubled. Okay, your rich gunkle comes along and says that he's going to match whatever you got. Gay uncle.
I thought it was great.
No. It means it gets half as close, right? So we got to remember that one's always by reciprocal. What about H? Remember, it's grouped in with X.
Horizontal shift.
Okay, that's my horizontal translations, and that is backwards land. And then K is my vertical translation. We beat this stuff to death in Algebra 2 with a lot of functions that we knew about. If you continue to progress through math, you're going to start doing this to some really wild functions. Or not even functions, but just relations.
What's the function that creates a circle? Like on your graphing calculator.
That's a geometry standard. You should have already created that.
I didn't.
Oh, dear God.
Yeah.
Well, next week's going to be fun. Because next week is conic sections, and we will talk about that exact same thing when we do ellipses. So, these are all of my parent functions. I want you to think about this and what's going to change if I say y is the arc sine of 4x. What's going to change? Is that 4 in the A, B, H, or K spot? It's in the B spot. B spot is horizontal stretch or compression by the reciprocal. So instead of going out to plus or minus 1, it's going to go out to plus or minus 1/4. You want to know how we graph those? Ta-da! That's it. Like, that's how we're going to graph it. Okay? We're going to change the axes to match what we're doing, just like we have been all chapter. What if I said that? Is that in the A, B, H, or K spot? It's in the K spot. That's vertical translation. Where it gets weird, isn't my vertical axis in terms of pi? So how do I add 4 to it? I literally just add 4. I say 4 plus that. I say 4 minus that. Ta-da! I turn that 0 into a 4, and then I just have to have compound numbers north and south of it. Okay, so graphing these is actually pretty easy. Boop. Arc cosine of 2x. So regular, you don't have to put this one on there. Regular arc cosine of x. What's my domain?
1 to 1.
Negative 1 to 1. What's my range normally for arc cosine? So I'll go from 0, here's pi over 2, here's pi, and we go from negative 1 pi, 0 pi over 2, 1, 0, but you try to keep it curvy. Does it curve down like this, or does it curve out like this? Which one was it?
The second one. That
Okay? Think of it as that serpentine curve like this. It's still going to curve this way. Okay. So how does this thing change if I now say y is arc cosine of 2x? It's going to go half as far. Now, your choice how you want to do this. I can move this point here and here and show literally the compression by 1/2. I can show that, or what I think most of you are going to want to do is say, bam, bam. Okay? So you start with the parent graph. Just graph the parent graph. And then go change your axes to match the new form. Okay? You don't have to show both on the same set of axes. I just wanted you to see what the compression looked like. Both, go! Graph the parent function. Start with that. Then go change things.
Sine to the negative 1 and arc sine.
Mm-hmm.
But if they both go to the tangents, that's probably what's happening.
Yep, it's like your full name versus your nickname.
Which one's the nickname?
The negative first. I mean, is your name really Max or is it Maximus? Oh.
Or is it Maxwell?
Oh, Maxwell. Yeah, never thought of that. Okay. Maximus sounds cooler though.
Bro, the way you just
What did you just say?
curvy like someone.
It's gotta be 3x.
Curvy like who, Max?
No one. Just a marker now.
Watch yourself. And to be fair, I've heard them all. Curvy like, yo, mama. Okay. So, just like we were just talking about, arc sine. I would go from -1 to 1, from negative pi over 2 to pi over 2 normally, from here to here to here. I did those backwards. Here to here. There we go. If this is normal sine, then I'm going to squish that into a -1/2, 1/2, or a 1/3. Could I even keep it to that scale? -1/3, 1/3. You see how it gets funky when you try to match scales? Because there's 1/3 of the way. It would have to look like this. Because it was a horizontal compression by 1/3. I'm showing you the original compared to the new one. If I had to match scales. Isn't it a lot easier, instead of matching the scales like this, to just get this out of here and say, third.
Okay.
Right? But you see what I mean by it is actually that 1/3 compression. Okay? Trying to match someone else's scale is what really ruins this. That's why this is called pre-calculus. Because in here, I'm going to get you ready for trig and calc. In here, we're going to make our own scales. Next year, yeah, you're going to match their scales. Okay? You got to be able to fraction. You got to know what's going on. Okay? Tangent. Normally, at negative pi over 2 and pi over 2, I have asymptotes. Normally at negative 1 and 1, 0, 0, there we go. I would say that the arctangent of 1 is pi over 4. The arctangent of negative 1 is negative pi over 4. I'd connect the dots like so. If I want to change this to a 2x, I can either squish those in to here and here instead, half as big, like this, and then it actually does start looking like a cube root. Or I can map my scale to work for me like this. Okay? So I'll let you choose. I'm just going to give you a blank graph and say, do it. Now, someone was also asking, how do you graph these on your calculator? Because, oh, you can. It's just, if I go to y equals and I want to do, say, clear, and clear. Say I want to do the arc sine of, well, just arc sine of x. We'll start there. I hit plain old graph. I don't see too much, right? But if I understand how the graph works, maybe I'm going to go from negative 1.5 to 1.5 so I can see the ends of it. Go by ones. What do I do the y's on? What's the range of arc sine? No, that was my domain, was negative 1 to 1. Okay, how big is that? Pi over 2, 3.141592 divided by 2. So what if I went to like negative 2 and 2? And then look at it? Okay. So basically, in order to graph your periodic functions on a graphing calculator, you kind of got to know how to graph them anyway. So it's easier to just do it yourself. Okay. That's where the other class left off, I'm pretty sure. Right? Yeah. Because then tomorrow we'll do a little bit of review and then move on to the last part. No, Papa Bear tired.